Welcome to Home Tiny Lab. My name is Christoph, and in this video I am going to show the difference or what it means in XCP-ng and Xen Orchestra, what we mean with static memory and dynamic memory. So let's go on. So here we see the desktop. Everything what's on the screen is running on my hypervisor XCP-ng. So we see the virtual machine that's running Xen Orchestra. We are seeing here the whole environment, my Pop OS workstation that's running also on my little server. And here we see the resources used by the virtual machine that's running Xen Orchestra. Let's have a look at what we can set as memory parameters when we are configuring a new virtual machine. So selecting the pool for the virtual machine, and now going selecting a template. I'm going for the first template in the list as an example. And here you see immediately that some values are already filled in for you. You have already the number of CPUs that you can change. Then you have the RAM that is assigned. The value that you are seeing here is in fact the maximum memory that can be assigned to the virtual machine. It's going to be clear when we are going to look further at this. Let's select an ISO. Not corresponding with the template, but it's only for showing what's happening with the memory. In fact, if here, because this is the maximum, they are not showing what's the minimum of the template of the virtual machine. So for example, if I want to go below 2 gigabyte, there's a triangle showing up, and when you are hovering over the triangle, you will see the memory is below the threshold, and the threshold here for this template is 2 gigabyte. So if I would say 2 gigabyte, nothing is showing up, it's good. But I'm going to set 4 so that I can show what dynamic memory means for XCP-ng. So one network is associated, and I'm using here the local storage SSD and 10 gigabyte. Let's change this to the mechanical hard disk. And I'm not going to show the advanced settings, but I am instead going to create. So now we can start up the virtual machine for installation, but I'm not going to do this. So we are going to the advanced tab. Once in the advanced tab, and when we go a little bit down with the scroll wheel, we have a section with virtual machine limits. In fact, when we are creating our virtual machines, what we are setting are the limits. So for example, for memory, the limits minimum maximum for in the static is minimum 2 gigabytes, maximum 4 gigabytes. Now the system is not booted up yet, so we can change still this value. So I'm going to set 4 again. And the minimum value, you cannot change it because it's by selecting the template that this value was set to 2 gigabytes for Alma Linux. But in the dynamic range, we see here that minimum value is 4 and maximum also is 4. This means that for this virtual machine, the memory is static. So when we are booting up the memory, it will always take 4 GB of the memory available on the system. But if we change here the minimum value, for example, 2 gig, what's the minimum static value? If there is no 4 GB available, but there is, for example, 3 GB available, the system will still boot. And if memory is freed up, it will change to 4 GB if possible. So this means some overhead for the system when we are using this kind of memory configurations with minimums and maximums that are the same. It's static. You put a difference here. It's scalable here between 2 and 4 GB. For example, I can still change this to 3. And then the maximum for the virtual machine will be 3 GB. And the minimum for the virtual machine, 2 GB. So this is a little bit the explanation on how the memory will be assigned to the virtual machine. Okay, let's go up again and remove this virtual machine. So when we are looking now at the host where the virtual machines are running on, we will see that there are 3 virtual machines running. So if we look here, we see that 8 GB is used of the available 8 GB present in the system. So if we look a little bit closer to one of the virtual machines running, let's take here the one that is taking the most of the memory. It's our Xen Orchestra appliance that is using a little bit more than 3 gigs. Here I have launched a terminal session of my Xen Orchestra virtual machine. And here you can see again that there is 3 gig, a little bit more than 3 gig assigned to the virtual machine. It's an odd number, and we are going to see why it's such an odd number. If we are going to the virtual machine and we go to advanced, and we are going a little bit down to the virtual machine limits section, you will see that the dynamic range is set to 1 GB as a minimum value and 4 to a maximum value. So the machine had already to free up some memory because there is not enough memory for all the virtual machines to run with their maximum memory. So there is left 3 gig and a little bit. So it's not using its full 4 GB that can be assigned to the virtual machine. The same for my POP OS that's running. If we are going to look to the virtual machine of my POP OS workstation, normally it's 2 gigs. That maximum can be assigned, and the minimum is only 1 gig and a half. Why are those numbers chosen? That's because if we go below some thresholds, the system is going to behave a little bit, let's say it's not the optimal way to run. If we look at the memory that's used, it's already 1 gig for, if we don't want that we are getting into a scenario where virtual machines are all the time swapping from memory to disk and the reverse, what's going to have a penalty on performance. It's running on an SSD, so the penalty will be lower than on a mechanical hard disk, but it's very important to well manage your memory if you are going for dynamic usage. So if you want to run this machine static, the minimum value has to be 2. So 2 means 2 GB will always be taken by this virtual machine. What will improve stability for that machine, and what I mean by stability is it's the optimal memory to let run this virtual machine. Why using dynamic memory? So if you only have a small machine, so I'm going to show what I am running as a virtual machine host. So I'm going to my host. And let's go to advanced. And when we look at what I have, the hardware, it's a CPU. Intel Core 3 4130. So it's only a 4-thread processor. So nothing really special. So this means that with a rather small machine you can have something run or have some instances running for your own lab. Let's go again to the general, and we see that there's 8 gig in total in the system. What's not a lot if you want to do virtualization. But let's say that if you want to run set up some home lab for some cases, here you can see that you don't need much. So this is why this channel is called Home Tiny Lab. I try to one with what I have on hand and showing what's possible with it. So we have only running now 3 virtual machines on the system. So for somebody who wants to try out some things, 3 virtual machines is a little bit at the low side. And I am already running Zen Orchestra on the system. What's something that's always running? My Pop! OS to have a clean environment to show something to other people or to test some programs out. It's also always running. And here I have my Pi-hole that's running for my home lab. Almost all the time also. All those machines are running from my SSD. So if I'm going to look at storage, I have as local storage and SSD and local storage and mechanical hard drive. And on my local storage, my most important virtual machines are running. The ones that I consider as operational are running there on. So, what do I want to show? That is how much virtual machines can we run, and is everything still working when I'm running the maximum virtual machines possible in my case, because there are people that can run more than what I'm running on 8 gig. But I'm going to show that's possible to run more than enough virtual machines on 8 gig and still doable, depending on what we are running on those virtual machines. So let's boot up some virtual machines. So I have already prepared some virtual machines for testing this. So let's go to virtual machines and let's set no filter. So 3 virtual machines are running. Let's have a look at the memory assigned maximum values, and let's boot up, for example, the Docker server. So starting up, and let's go back to the host and let's have a look at the memory, how it's behaving. So we have 3 virtual machines. Some space is made free to start up the 4th virtual machine. So still starting up. And we will see that some memory now is assigned. So there is the Docker server. So you see there is a 4th machine and all sizes. You see here, you can see that the memory went down. It's now below 3 gig. and here there was taken a little bit also. So let's boot up some other virtual machines. Let's no filter. And now I'm going to boot 2 virtual machines at once to see how the system is going to behave. So let's start. Okay. Now let's go back to my host and the memory. Some memory is going to be freed. And now there are 2 systems for now, and some more memory is freed. And 2 systems are assigned to that memory, and they are starting up. And here we see that the memory is going down again, and here also from 1.8 to 1.6. So, and we have 6 virtual machines running on an i3 processor with 2 cores, 4 threads, and a system with only 8 gigs. Let's see if the systems are already booted up. I don't think so. They are still booting up. But let's try to get some more virtual machines running. So let's go to virtual machines. I set the filter off. And let's boot 1 virtual machine. Current status is starting. Let's go again to the host where everything is running on. Some memory is already freed up. Here the memory went down again, and normally this will show 7, and memory is assigned. So I know already, because I've tried this out before filming, that my maximum in this case, with the machines that I have configured, my maximum is 8 in this configuration. So let's prove this, that I can run 8 machines. So setting the filter to none, put, selecting 1 virtual machine, clicking on start. Okay, let's go back to host and to XCP. Memory is freed up again, and now there has to be 8 here as virtual machines running. It takes more time. The effort for freeing up memory and assigning it again to another virtual machine. Now we have the 8 virtual machine, and the memory is assigned also. So, and here we see that we went down again in our maximum virtual memory assigned. Not virtual memory assigned to our virtual machine. So we are running 8 virtual machines on a system with only 8 gig of memory, but there is a performance hit. So be careful when you are assigning this way memory. Your system management has to be spot on. So let's try some things out to see if every virtual machine is working. For example, let's start up a backup. I will make another video how about I'm doing my backups, but let's say that every virtual machine is backed up every hour, and when I click here on start, it will run the job. So I'm clicking on this. 12 machines will be backed up, and the backup will be started. So it's taking snapshots of the machines and then exporting them to my storage that is assigned to the backup. So it is working, and the system is not taking much memory up. So this is my virtual machine where an orchestra is running on. So it is busy let's go to the virtual machines and let's go to one of the Ubuntu's that's running. Let's take this one. Let's go to the console. Let's log in. So I am in the system. Use all the screen. Let's do a sudo update. So the virtual machine works. So all virtual machines are really functioning. The only problem is if I'm now going to look at my number of virtual CPUs assigned, I have 32 virtual CPUs and I only have 4 physical CPUs. So you can over provision easily. If your systems are not taxing the processor at its maximum, can really optimize the system that you are using this way. If I look to the RAM, you see that everything is assigned. Let's go again to the virtual machine console. It's the correct one. So as he has done this, there are some updates to do. So I am going to do the update of this machine to show that everything is still working. I'm setting yes. And the system is upgrading. So I am running backups, updating the system, and I have on my host 8 virtual machines running. Okay, let's have a look. Virtual machines again. And let's say that I want to stop a virtual machine. We will see that memory will be reassigned to the working virtual machines. So 1 gig 6, 1 gig .06, 1 gig .6. That's what's assigned to Pop! OS and an Orchestra server. And I'm going to stop one virtual machine. And let's have a look to the host again. And 8 virtual machines still running. Normally it has to go down to 7. Memory is freed up. And let's see, okay, I see here that already the memory went up. And memory has been assigned to the other virtual machines. Let's go again. This is the machine that's updating. So this I'm going to let run. I'm not going to stop that machine. So let's go back to VMs. And let's stop 1, 2, 3 machines that I'm not using. And let's stop. Are you sure you want to stop 3 virtual machines? Okay. Let's go to hosts. So from 7, I normally have to go to 4 virtual machines running, and memory has to be reassigned to the virtual machines. It's going to take a little bit more time because I'm stopping 3 virtual machines. 1 is stopped, 2 are stopped, but I think that he is still busy. Let's check this in the VMs. He's still stopping the Docker server. Now let's go back to hosts. It's taking more time. That's the only thing that's happening. Okay. We're down to 4 virtual machines, but memory still has to be reassigned to the running ones. Here I have 2 gigs, 0.02, and it went up to 5.3. And here we see that more memory has been assigned to the running virtual machines. So I hope that it was interesting for people who are not having enough memory in their system to assign everything statically and to have enough headroom. So if you want to have a home lab with 1 machine with not enough memory, I think that if you are running an hypervisor like this, it's going to be difficult to go below 8 gig. I think that the sweet spot to have a quite normal behavior and to play around with some virtual machines for testing out some use cases for a lab. I think that 8 gig is the minimum, and that running it from an SSD is almost a must. The processor, everything above i3 or let's say a 4-thread processor is welcome, but I think that for people that want to start, there is no reason not to do it, even on a system that is at the low end side. So thank you for watching, and if you want to see, if you are interested in home labbing on small systems or with small resources, don't forget to subscribe. For the moment, I'm only working on videos on XCP-ng, Xen Orchestra, because the two go well together, and TrueNAS Core. So I didn't migrate it for the moment to TrueNAS Scale. I will only do this when I have tried out TrueNAS Scale on another system. So thank you for watching, and I hope that I will see you back in the next video. Thank you for watching.